In the last lectures, we have discussed about the one sample Z test and one sample T test. In this lesson, we'll talk about the two sample Z test and two sample T test. So let's have a quick look at the learning objectives. Please pause the video and have a look at the objectives. I'm just rushing to the first test which we'll learn. So this is the formula for the Z test for two samples. So like we have calculated the Z value in one sample Z test. In this case also we have to calculate the Z value, but this value will be based on the two samples. So we have to calculate the sample mean of the sample 1, that is x1 bar, as well as for the second sample, that is x2 bar. And for population mean, we assume in hypothesis, null hypothesis, that these are equal, so this value will take at 0. Then population variance, sigma squared 1, that is for sample 1, and sigma 2 square, this is for sample 2. So these are the standard deviation or variance of the population. So population variance we should know to calculate the Z value. N1 is the sample size of sample 1 and 2 is the sample size of sample 2. Let's have one variation of this formula. In some cases you will not be supplied with the population variance. Here for example we need these two values, this one and this one. So these two values sometimes are not supplied. In practice we plug in the values of sample variance. So here one alternative formula for the Z test is also this one, except for this thing, everything is same. So we can plug in the sample 1 variance and sample 2 variance in this formula. So let's quickly have a look at the one of the problems we'll solve. Here the sample has been taken. I'll advise like you just pause the video and read it carefully. I'm just coming to the point. So the two brands A and B, and sample from each of these brands have been taken here for 35 for A and 40 for B. So these many samples has been taken. The sample size is 35 and 40. And for the average life has been calculated, taken for each of the observations. Now the question is whether the average life from brand A and brand B are different or not. Taking 95% as the confidence level. So if 95% is the confidence level, our significance will be 0.05. Level of significance alpha will be 0.05. So let's have a look at the data. This is the data for, say, this is for brand A and this is for brand B. We need to calculate the different values which we require to plug in the formula. So what we need to calculate the x1 bar, which is the mean of all this data. This we need to calculate. We need to calculate the standard deviation or variance of this sample as well as this sample. So here x2 bar, and then sample variance or standard deviation. We'll calculate this one for sample 1 and also for sample 2. So and then we'll plug in the values. N1 is given number of observation here, N2 total number of observation for the group 2. So these values we'll calculate and plug in. So let's quickly have a look. So this is the data is given here. You can just either use Excel or you can use calculator to calculate the mean values for each of the samples and the variance for each of the samples. So the formula for standard deviation, you can use this formula, or you can just directly calculate using the function in Excel. But for exam purpose, you have to learn how to do it by hand. So you have to calculate the mean by using simple calculator. So mean you can calculate, add all the values, divide by number of observations for each of the samples. For calculation of variance, you just calculate this value, xi minus x bar squared, and add them all, divide by n minus 1 without doing the square root. So square root, it is the formula for the standard deviation. So if you do not take the square root, it will be just the variance. So now we have calculated these value, variance and mean. We have to plug in these values in the formula we have. So now let's quickly have a look at this. So we have formed the alternative hypothesis, that is these two means are same, and null hypothesis. The null hypothesis that these means are same, and alternative hypothesis that these means are not same of each of this population. Then we have to calculate n1, we know 35, n2 40, variance of sample 1, variance of sample 2, mean of sample 1, mean of sample 2. So if any of you do not know how to calculate variance, I have a separate video for this, how to calculate, very short video. So if you do not know how to calculate, I have explained how to calculate it by hand. So you have calculated all these values. Now plug in this formula. So x1 bar is this one, x2 bar is this one. For sample A, brand A, all the mean value, and this x2 bar is the mean value for brand B. And this value by default, as told you earlier, it will be 0. And plug in other values. For example, here we have plugged in the variance for sample A, sample size, variance for sample 2, sample size, and then solving we'll get this value, minus 1.68. Now to know whether this Z value is like how much probability value, or whether we should accept or reject the null hypothesis H0, that will depend on our critical value for Z. And the critical value for Z will depend on number one, the level of alpha. So level of alpha in our case was 0.05. Okay, and was this test one tail test or a two tail test? So we can see here the not sign, not equal to sign, and we discussed earlier, when there is a not equal to sign, we will consider as a two tailed test. And for your information, those tests which we just do greater than or equal to, they are considered as one tail test. Here it will be a two tail test. So corresponding value for this much alpha, the Z value, the threshold Z value for two tail test is 1.96. Now the decision, how do we make decision, is same as we have done for one sample Z test. We compared the calculated Z value with the critical Z value, and it should be greater than our calculated value. If it is greater than the Z critical, we decide that we reject the null hypothesis. In present case, the calculated Z value, of course, is not greater than the critical Z value. It's just opposite. So we cannot reject the null hypothesis. And what will be the conclusion of our test? That these two brands, they are not different, they're just equal. They're from the same population. Okay, so this is how we do it and how we make conclusion based on the Z value. So in next lecture, I'll talk about the two sample t-test.